So, good morning. I'm not an academic, so I need PowerPoint to speak. So what I will cover today is basically, I'll speak a little bit about IBM Research and what we do and where we are and why we are where we are. Then I'll say a few words, really, if you want a case study about our collaboration in Zurich with ETH, the Federal Institute of Technology in Zurich. And in the end, come really to what the title here says, the 21st century scientist. At least that's the kind of person that we look for in IBM and specifically also maybe in IBM Research. And I hate to say this, if they read a few books on innovation, that's fine, but I wouldn't hire an entrepreneur like Carl Schramm suggested, nor would I hire somebody who's studied innovation and hasn't done anything else. So with that, I'll get into my presentation. So IBM Research has by now 3,000 people that work, scientists and engineers that work across the world. We're a small portion of the IBM company with more than 400,000 employees. But we are one of the sources that IBM looks for in terms of innovation and new technologies. And of course, I mean, disrupting actually is a difficult thing in a large enterprise. So most of the stuff that we actually do turns out to be of the character that we continuously innovate and we just improve existing things, or we sometimes, of course, we come out with new things that may not appear disruptive, but certainly to the people skilled in the science, let's say, of making chips, we'll find that instead of having two-dimensional transistors, suddenly having nanowires as transistors is in fact a fairly disruptive thing. The 12 labs that we have across the world were started really in multiple waves. The first wave was to be close to universities. In fact, the first lab, the Watson Research Lab, was started at Columbia University right after the war, when everything needed to be invented about really computers that we wanted to build for the commercial sector, not to break codes like had been done during the war. The second lab got started at close to Stanford in San Jose, our Almaden Research Lab. And the third one, IBM then branched outside of the United States to get access to European talent. And we started some 58 years ago in Zurich, the Zurich Lab, to be close to ETH. Zurich, again, you know, a source of talent that we could hire from and that would have potential to actually collaborate with us. The second wave of expanding was to be in growth markets, what IBM calls growth markets, emerging markets, India and China. And we did this actually before the world was considered to be flat and before everybody talked about globalization. We were in China in 1995 and in India in 1997. And the third wave now is really to go to where, and both of these labs in China and in India also got started in India, again on the campus of a university, in China, in Beijing, where many Chinese universities are, important Chinese universities are. The third wave of starting labs was to be close to where interesting problems are. So in South America, in Brazil, in Africa, which was a lab we opened last year, in Nairobi, in Kenya, and in Australia, where we would have interesting problems to work on, and specifically things that we would not work on in an established country like it would be Switzerland. Switzerland has clean water, so you don't need to really work on on be it water management solutions or other things. That's all solved. And we also have traffic jams, but no comparison to a still growing country like Kenya, where a lot of people move into Nairobi, and the city is just growing in a fairly unstructured form or manner, and there you need to actually plan, and you can apply IT to better traffic management. So those are the reasons why we actually went to the various places. But interestingly enough, even in Kenya, we're on the campus of the Catholic University in Nairobi. So always to be close to universities and in the intent of really partnering with them and using them as a source of talent. Okay, I guess my Spanish isn't good enough, but what it says is there's not enough memory to show all the pictures here on the slide. Doesn't matter really. The Zurich Lab is one that, as I said, it's fairly old. We have a good history in terms of really working in atoms and at the atomic level. We discovered or invented really the scanning tunneling microscope in 1986. It was awarded a Nobel Prize, and we also did material science research and came up with high temperature superconducting materials, for which we got another Nobel Prize in 1987, so following year, which is nice for an industrial research lab, and it sort of puts you firmly into the company in terms of the value that you provide to the company. But we've also done other things that are in IBM's products, and the products such as products we no longer do, but you all have. If you have a broadband modem, all the single processing that takes place inside the modem, the algorithms were invented at the Zurich Lab. So we cover things, in fact, the entire stack. The buzzword of today is big data, cognitive computing, all the way down to atoms. And we still do this with about 400 people. Now I'll really come to my case study really around our collaboration with ETH. And for that, when the lab got opened, here's a quote you can read from Thomas Watson Jr., who was sort of IBM's president and chairman at that time. And that's what he said at basically the opening in 1956. And when we look at the collaboration with ETH, yes, we hired, in fact, at the very start in 1956, if you look at this timeline here, we hired people from ETH. The first director of the lab was not a professor, but an assistant professor at ETH, and we hired him away, and he headed up the lab back then and built it up. But I must say, in the early days, other than people actually moving from one location to the other, working for us, or in fact going back to academia, becoming professors, we really didn't do much in terms of really extensively collaborating. In fact, it was just exchange of people. It wasn't doing projects in a joint fashion. In fact, even the Nobel Prizes, I mean, yes, the older gentlemen, they came actually from ETH, and they were sort of honorary professors at ETH, but they worked for, for IBM. But it was people. In the 90s, we elevated this somewhat, and we started doing joint projects with ETH. In 2001, and you can see me there up on that picture, we opened something which was novel. It was a joint center to do advanced silicon engineering, so advanced designs really on silicon platforms that for high performance computers, so signal processing, other types of things jointly, where we made available the technology platform, the tools, and ETH actually could work with those tools on those manufacture actually then chips also in our factories in the US. And that was sort of a first step. And then we increased it. We grew other things. We started a center to do joint research in computer security and privacy. And then something interesting happened. The folks in my lab that do in fact nanotechnology and research around nanowires and what's required for the next generation of computer chips, they came to me and said, we need a new clean room, because the old clean room, which was built actually in the 70s, no longer really holds up to what we require in terms of the equipment that we have or would like to buy. Doesn't fit into it anymore, nor anything else. And I said, well, that's all very nice, but a new clean room is an awfully expensive proposition, and all the equipment is even more expensive. And all we do is we do research, and we have about, in that field, we have maybe 50 people. And so you can imagine it's a huge investment to do something like this. And basically, I went to the US, talked to my boss, and he said, well, get the government to pay some of it, then we can do it. Because in the US, clearly, state of New York does a fair amount of subsidies to bring chip industry into Albany, and there's a whole cluster now just because of huge government investment. That's not the notion in Switzerland, and so I was basically told, yes, you can do it if the government contributes to it, but no, the Swiss government actually says we don't give money to private companies. That's the reason why we actually pay low taxes, and I think in part why we have the feeling in Switzerland, more than in other European countries, we're really responsible for our own fate. It's not the government who takes care of us. What happened then is at a party organized by a company, I met a friend of mine who I knew, and I told him about this problem. He works for another company, and he said, well, you should meet the new vice president for research of ETH Zurich. And he introduced me to him, and I told him, we want to do a new clean room, and what are your plans? And he said, yes, we also want to do a new clean room. And then very quickly we said, well, we should do something together. We met the following week, this was October. In November we signed an MOU. In June we signed the contracts basically, and the lease agreement for ETH to rent space in the clean room. We announced the whole thing in the June of 2008, and in 2011 we opened basically the new facility. That picture was actually laying the ground stone, foundation stone in 2009. So you can see from first conversation, October, MOU, November, contracts ready, June, very fast. And what's interesting, had we spent any more time on it, we wouldn't have this facility. Because what happened in 2008, you will all remember basically the big banking crisis and money, actually, basically the banks going belly up or needed to be bailed out, and the economy really coming down, crashing. And clearly then IBM wouldn't have been really willing to spend that kind of money. And the kind of money is basically 90 million for 60 million for the building, 15 million from IBM side for the equipment, so 75 million Swiss francs, or make it dollars, it's the same thing. And, well, unfortunately it isn't the same thing. I wish it were. Dollar is fairly weak. And 15 million from ETH for the equipment. And so now we operate this as a public-private partnership. It was built on our campus, and it's run really as a joint facility. And we now have basically more than 100 people that use this facility now, that do their research, and we both get to use equipment that neither of us would have been able to afford to buy. ETH, had they wanted to, and they had plans to build a clean room, a new clean room as well, they would have had to go in front of Parliament to get the budget for it, and it would have taken years. They'd probably be starting to build now, not at the time when we started. So it was really beneficial to both parties. Now I'll come to the second part. What do we look for in sort of future scientists, and sort of what is our view of these things, and what's important to us? And I'll have to start here with the origins of computer science. Basically, when you think back when industry came out with computers, there were no computer scientists. There were mathematicians, there were electrical engineers, there were physicists, but there were no computer scientists. But for us to be actually successful in the market with computers, you needed people who knew how the computers worked, you needed people to program the computers, and in fact it turns out you needed a new science, computer science. A new, if you want, engineering discipline that would allow us to deal with computers. And so this is how these things got started, basically, as a new field of research. And I would put to you that next thing happened is we identified another area of scientific field of exploration that I think universities should be offering, which was services science. In fact, we call it service science, management, and engineering. Why is that? Because we as a company started in the early 90s what is now really a large business, not only by IBM, but many other companies, which is called outsourcing. And clearly when you think of it, all the out-tasking and outsourcing that takes place, jobs moved into India, into large shared service centers, shared facilities. That is not an easy feat. In fact, that's worth managing, that's worth engineering, that's worth studying, that's worth optimizing, that's worth understanding. And that's how this service science, management, and engineering came about. And I'm proud to say we actually really made a huge effort. And by now, hundreds of universities really offer this as a master's program to train people in this, and people that essentially we would hire then because they bring those skills with them. Next step, again, around computer literacy and around using computers for other areas. A program we started, other areas than what they've been traditionally used for, which is back office automation, you know, when you book an airline ticket, book a flight or so. I mean, that's when a computer comes in. When you do an ATM cash withdrawal, that's where a computer comes to. Old stuff. New stuff now is basically what I mentioned with our labs, doing water management, doing traffic engineering, traffic automated control, modeling entire cities. That requires some foundation of computer science and some knowledge of computer science, programming, systematic thinking, thinking in models, and so forth. So what we started in the US is a program very innovative, leading to an associate degree. So it's grades 9 through 14, 14 being 2 years beyond high school, to teach people, which is called P-Tech, degrees in applied science, engineering, and computer science. And then these people would go off and get a job maybe, could be getting a job, would be employable because they have some of the necessary skills, or they could go on to a bachelor's and master's eventually. But again, those are people that we would also need, or that our customers would need in order to make use of the technology we would provide. So the new face of person that we look for, and here it says innovation, is somebody who is T-shaped. T-shaped meaning that people have deep knowledge in a technical field, but they also have an understanding of what goes on elsewhere. And they have an understanding, at least to the level that they can converse with somebody who's deep in another technical field, and in fact collaborate with that person. So they can translate whatever they do in their field into a language that's understandable to the other person deep in another field, to allow for cross-disciplinary or interdisciplinary work. That's what we really look for. Here is sort of the career of an IBM scientist, the people that we look for in IBM Research for sure. We start really with entry-level people with a PhD, or if they don't have a PhD, we start people as so-called pre-docs in our lab. It's a program where people work part-time for us and part-time pursue a PhD at a university. Ideally, the project they work with us on is one that will lead them to a PhD, so there are synergies involved in it. And then people can progress along a technical career that all of the way culminates in an IBM Fellow, which is a title that's very rarely given in the entire IBM company. We have some 74 fellows of 400,000+ employees. So that's at the same level as an executive in the IBM company. Those are the people that follow the managerial career. But this dual career path is important because clearly you need to give people, and this was an innovation in IBM a long time ago, you need to give people a reason to stay in the technical career if they're good, and pay them just as well as you would pay people in a managerial career. And so one of the things we look for in our technical population is also to teach at universities and also go on sabbaticals every now and then, not quite at the pace at which maybe academics do it, but and in fact this morning I spoke to a colleague from the keynote speaker of tomorrow about this. In industry, one of the challenges we have, there's always things that are more urgent, and then there are things that are important, and the important things never really are the urgent things. And so this is why with a sabbatical then management also has to sort of keep track of these things, because the good people are typically in one project and then they go on to the next project, and don't take the time out that they probably should be taking, just because going somewhere else brings fresh ideas, brings new approaches, and is very helpful. So and again, I guess memory doesn't suffice, so I'll skip this chart. I'll come to the summary. So what I was telling you is three things really. A little bit history of IBM and IBM Research, and that we really value the fact that we can go and work with universities and in fact start things close to universities or inside universities. But in summary now, from what I told you, the second point of my talk, this public-private partnership that we've started with ETH, is you need to recognize that industry and academia have different timescales, and if you really want to do something with industry, you need to adapt to their timescale. I remember still when we had those negotiations about the contracts, one of the sticking points was IP. What would happen with IP? In fact, IP we could solve by and large because we had prior contracts with ETH on research projects and how we would deal with IP. But there were certain things that ETH, because it was such a big thing that they wanted on IP, that we needed to find new creative solutions for, and it took some time also inside IBM to get agreement, and then in ETH and so forth. And then the negotiations we had, they always ran into way into the night. In fact, the last negotiation, I think, ended around 1 o'clock, and then our lawyer basically sat down and until 4 o'clock wrote the things down and everything. And the ETH guys came to me at one point in time and said, give us some breathing room, we need more time, why is this deadline? And I said, well, that's the deadline and we need to stick by that. And I'm glad we did. As I said earlier, the reason we wouldn't have this center. Certainly, my experience is start small, and that's how we did it over the years with ETH. Get comfortable with fewer projects, build sort of confidence in your partner, get to know them. The personal relationship is of utmost importance, I find. What is interesting, I managed now, I've been a lab director twice, and really for a long time, if you total it all up. Personally, and my team actually managed now to have really long-term relations, one-on-one, with key stakeholders in the university. And that, in fact, helps then to do the larger things, because we both know what we can do, what we can't do, and we can talk about it. Protecting IP, as I said, there's always ways to find creative solutions, but you need to realize, at least this is my personal opinion, I'll say that, industry is in a much better position, and startups, to do something with IP than universities are. And so the role of a university should really be to enable industry or startups with IP, not to look at the IP as a source of additional income that the government may not be giving to the university. That's a fallacy, and usually doesn't work. I believe, from what I've heard, there are two universities, Stanford and MIT, that actually draw a lot of money from the IP portfolio that they license. Most other universities don't do this, and in fact their tech transfer licensing organization costs more than what they bring in. If you really do the full cost analysis, what they bring in IP revenues. So I'm all for protecting IP. If the inventor is in the university, that's their IP and they should have it, but one should come to sort of a reasonable agreement in how you transfer the IP or how you get access to the IP, and not sort of expect this will in fact be the next MP3 that will fund you for the next 20 years. There's very few MP3 patents of that nature. And then build what we find with the larger projects, then really build strong governance models. Governance models, because now we have, and this is very unique, we have on our campus, in a building that's on our campus, for professors, their students, PhD students, assistants, and so forth, about 60, 70 people full-time there. They need to order things. So they need a receiving facility of some sorts. They get mail, they need to eat somewhere, and so forth. All these things we had to work out in the course of really running the project. And for that, sometimes it came to me, and sometimes it came to the president of ETH, and we can sit together and then find solutions. The governance model is a key thing, because there are people lower in the organization that may not see the importance of why they should be doing this for the other party, or why this is important to the other party. And so that's a key element. And then clearly finding synergies beyond individual projects, that's what leads them to the larger affairs. So with that, I'll conclude, and hopefully we've made up some of the time lost at the beginning.
Well, thank you, Matthias Kaiserswerth. Floor is open for questions, and there's right a person who is willing to put a question. The flying mics, please. Maybe I start with a small question. You said and started your speech with quoting or saying you are not going to hire people like Karl mentioned, innovation, entrepreneurs. Well, okay, but what is the profile of the academics you are looking for in future? What do they need to fulfill? They need to be brilliant technology people, but what else?
Yeah, I think what we look for is they need to sort of have this T-shape. So as I explained, deep in a technology to translate this so they can talk to other people, understand other people, have this breadth. In addition, what I think I'm looking for is people that have some, and this I would like actually, entrepreneurial spirit, that really want to do something on their own, that want to swim somewhat against the mainstream, that come with fresh ideas, and that have the passion to push these ideas forward, that are able to basically build, and in a large company, I will tell you, you always have more people that will say no than people that will say yes to something new. And but sometimes even a large company turns out an innovation. I mean, it does happen. Otherwise, they wouldn't be around and wouldn't exist anymore. You need to understand and learn how to do this, build sort of work with stakeholders, understand in fact what a stakeholder is. If you are a startup, stakeholders doesn't have too much meaning to you because all you worry about is your employees and the customers. But in a large enterprise, stakeholders, learning about stakeholders, how do you manage these, that is a worthwhile skill that could be taught, I suppose. And then the fact that you need to get people into critical thinking, question the way things are being done. Because in a large company, you're always being told, we've always done it like this, or this is the way we do it, or this is the process that sort of prescribes how we do it. And you need to people who say, well, we should be doing it differently, and translate this then into actually doing it differently. So in that sense, I also want entrepreneurs, but slightly different.
But you're not far apart, entrepreneurial thinking and acting. That's what we are looking for, and there's a message to all of us. But there's a question, please, yeah. Go ahead.
Good morning. My name is Jesus Ruiz from Banco Santander. You talked about the cooperation between IBM and ETH, Zurich, but are you cooperating with other universities in general in Europe? I'm not talking about the IBM academic program, but as IBM Research.
Yes, of course. We have very extensive collaborations across Europe with at any one point in time, we run about 90 different projects with universities across Europe. I mean, we are involved here in Barcelona with the Supercomputing Center. Some of my researchers have spent time here. We go where, in fact, there's attractive skill in an area that we really need and where we need to basically tap into knowledge and know-how for specific problems that we may have. And ETH is, while it's really one of the best schools here in continental Europe, there are good people elsewhere as well. So the key universities, yes, we have very, very good collaborations with as well, but not to the level of a joint investment, joint facility as we have because of the proximity with ETH.
Are there more questions to our keynote?
Over here. Lars Frölund from Aarhus University. Thank you, first of all, for a very inspiring talk. And some of the things that sort of rest most vividly in my head is the sort of the big variety of different forms of collaboration that you have. Speaking about, for example, the clean room, or you're speaking about the P-Tech. So my question is that how do you work, you meaning, for example, you in person, but also obviously IBM and your unit, with developing the concept of collaboration? How do you stay creative within how you collaborate over the years?
It's an interesting question. When I joined, in fact, after getting my PhD, my first job was in fact in the IBM Zurich Research Lab 26 years ago. And what was interesting then was, as I said earlier, we didn't have much collaboration. We had a very small project. And in fact, we were, as a company, this was prior to our near-death experience in the early 90s, we were as a company fairly self-sufficient. We had, in fact, a lot of internal competition around technologies, and we didn't look that much outside. And we really tapped only universities for talent more than anything else. And I think what brought the change about collaborating was, in fact, our near-death experience. The fact that it's change management, but it's very easy when you're about to die as a company to do change management. It brought about the notion that there was plenty of competition outside and that we, in fact, needed to partner with others in order to remain competitive and be competitive. And that brought religion to us along the lines, collaborate with universities, that's a good thing. And then the EU started the framework programs. And the framework programs were something, and there we're a little challenged now in Switzerland, at least this year. The framework programs were something that we found provided the necessary incentive also for us to go out and work with the universities, because we got some of the research funding from that, and in fact allowed us to grow our efforts. And so I think by now we've really embraced this notion of collaboration in any form, really, and I mean, you know, one can go beyond what we currently have. One can even think of joint ventures as public-private partnerships, you know, even in a legal form. That's an idea that I'm kicking around with my business developer, whether this isn't something that we should also explore. Because sky's the limit. I mean, you can do anything you want to if you find a good rationale why you should be doing it. And I think we're at this point now where anything goes, really, that makes sense for us.
Thank you. There's another question from this lady. Are there more people willing to put a question? Maybe we can have that second person right in. Yeah, thank you.
Thanks very much. Tshape from the University of Melbourne, and we're very fortunate to have the Australian lab for IBM. So it's more a comment about how you work with other universities, because I know from our I think it was a 4-year wooing of working with IBM to finally getting to supercomputer and all. But when we came on board as one of the partners, we never envisaged that it would help us with our other bilateral university partnerships. So for example, we had one with USP in Sao Paulo that had been basically an MOU that we just could not kind of get past the MOU stage. But it was once we joined the IBM Research Lab network, and we have the IBM lab in Sao Paulo, we've now been able to secure PESPI funding, and we have now joint projects between USP, University of Melbourne, IBM Sao Paulo, IBM Melbourne. And that's something similar we're doing with IBM Bangalore Lab, IBM Melbourne, with the Indian Institute of Science. So it's one of those things that we had thought was just about us working with industry, but it's actually pushed us completely into that next phase of working with our other valued university partners and something like IBM. So just a comment on how it's sort of bigger than we imagined. Thank you.
Can you pass it to, okay. Yeah. Can you put your second question right now, please?
How much do you work with other companies in research, and what is the most important thing when you work with other companies, with universities in research?
Okay, we do work a fair deal with other companies in our research as well, because for various reasons. On one hand, when you look at the computer industry, it has, by and large, what used to be very vertically integrated has horizontalized in some form or other. I mean, a computer is built with components from many different vendors that all form the supply chain. And so some invention that we make or we require actually to go into a future computer is something that we would never manufacture ourselves because we're not in that business, but we still needed to have a competitive offering or have a better offering than others. And so in that case, we have a research effort, advanced technology somewhat, And then we look for partners who would be in our supply chain to basically enable them with that technology, bring them, in fact, other clients, because otherwise they wouldn't be investing in that technology, bring other clients to them, so they, in fact, see a business case why it's worthwhile to invest in this technology and grow, basically, provide the market with that technology. With us, hopefully getting sort of first grab of that technology, and clearly, I mean, there is an IP deal involved in it and other things, but we work a fair bit with companies on that level, and then we work a fair bit with clients, if you want, to just try out technologies that we've developed in research in the market. And in fact, one of the interesting things that I see when you do research for the next generation computer chips, that's one model of how you do research. I mean, you basically do the fundamental science, the material science, and then you hand it off in the value chain, but that's largely still, in an IBM case, is still within IBM. And there are some partners that provide tooling and other things, so you work with those folks as well. But there's a discrete handoff process. When you do software, first of all, doesn't require much capital investment, and software is something that usually doesn't get written 3 times. I mean, it does get written 3 times, but you give the first version already to a client to try it out, and then you work out the bugs, so that's the second version, the third version, and so forth. So that is a model where we work directly with clients, and we in fact, increasingly now when you think of cloud type things, offering things in the cloud to clients, and then it becomes somewhat indistinguishable whether it's, I mean, Google is a good example. A lot of the stuff they have is beta. They withdraw it again from the cloud, but people actually use it for whatever. And so that's another model that we're now exploring, how to go about that. So we work with other commercial partners as well.
Well, we are running a little bit out of time, so I'm closing the session, not before saying thank you to our 2 distinguished keynote speakers. It was a great start into the conference.